So this week we're going to take a look at Chapter 2, which Chapter 2 is really just an introductory chapter to some of the themes that we're going to talk about this semester. But we are going to take a little bit of a look at what surrounds the Earth, meaning our solar system, and things that can be found in the solar system. And then Friday, we're going to bring it a little bit closer to home and take a look at the inside of the Earth. So we can start out thinking about the Earth in its place, right? So the Earth belongs to our solar system, right? So if we were to travel, say, through space towards the Earth, right, start at the edge of the solar system, we would see that our solar system is defined by the pull of sun's gravity, right? So we know that we're going to talk here in a second about all of our planets. They are held in place by the sun's gravitational pull. Anything outside of that gravitational pull does not belong to our solar system. Now, inside of our solar system, we can find some pretty interesting things other than planets, and of course the giant star in the center. We can also find fragments of ice and rock, right? Things like comets. We can see things like the Oort cloud way out at the edge. That Oort cloud is about 50,000 astronomical units from the sun. One astronomical unit is defined as the distance between the Earth and the sun, which is 93 million miles. So it's pretty far. The actual edge of the solar system is pretty far away. So the solar system itself is mostly empty space. Like I said, there's a lot of things in there, but it's mostly empty space. The boundary of what we're going to call the heliosphere is 200 astronomical units from the sun. So let's break down that word, heliosphere. Helio is the sun, right? So this is the outer reach of the solar wind. Now, when I say solar wind, I'm not talking about the breeze that we have outside. The solar wind is defined by the solar flares that come off, right? And the distance that they can travel before they completely dissipate. Now we can also define what's called interplanetary space. So meaning everything inside of this is where the planets lie. Neptune's orbit defines interplanetary space. So remember, poor little Pluto, right, isn't a planet any longer. It's basically a subplanet, right? So it's almost there, but you're going to see here in a minute that it doesn't really meet the qualifications as a full planet. So we use Neptune's orbit to really define where we start seeing our planets. So the solar system itself, here's a pretty good picture, right, of what we have. We can see the sun, of course, in the middle, and all of our planets. Now I do want you to notice Pluto again out there at the edge. Notice that Pluto has a really bizarre rotation around the sun. All of the other planets kind of lie in that same plane. It's called the plane of the ecliptic, right? So we don't have one planet up higher than the other or anything like that. They all rotate, right, in the same plane. However, Pluto over here, you can see it kind of goes up and then it comes down. And actually, it crosses Neptune's orbit in one spot. So Pluto doesn't quite follow some of these rules. You can also see here in between Mars and Jupiter that we've got an asteroid belt. You can also see that there's lots of comets that belong in our solar system as well. And then, of course, we've got moons, right, that go around the planets. So our solar system actually has a lot of stuff in it. So let's talk about the planets. So as I mentioned before, all of our planets lie in the same plane, and we call that the plane of the ecliptic. So the person that drew this picture here didn't just draw it and make it nice and even because it looks good. That's truly how the planets rotate around the sun. We have 8 planets in our solar system. The first 4, Mercury, Venus, Earth, and Mars, are called terrestrial planets. Okay. So terrestrial, terra, means earth in Latin. So these are all planets that are very much Earth-like. They're all made up of rocks and metals. We see plate tectonics on them, Right? We do have a rover on Mars now, right, these days, so we're learning a lot about Mars. It's pretty cool stuff. Now, our four outer planets, Jupiter, Saturn, Uranus, and Neptune, are what we call Jovian planets. These are our gaseous planets. So they do have a solid core, a very small solid core to them, but they are mostly gaseous. Okay, so you couldn't say land right here on the surface of Jupiter. What you're seeing there is the gases that are orbiting around the outside.